Dr. Ramachandran, I turn it over to you.
Thank you, Eric. Let me start sharing my screen. Okay, so thank you very much for this opportunity to talk about POccET Map. Simple to pronounce. It's the program on occupational health and safety education on emerging technologies, Mid-Atlantic Partnership. And so we are funded by NIEHS through this R25 grant. As the term Mid-Atlantic suggests, Johns Hopkins University, where I am, is joined by collaborators from University of Maryland, George Mason University, and Old Dominion University. The program's objective is to develop a comprehensive set of web-based educational modules in occupational health and safety, with emphasis on applications in emerging technologies, emerging contaminants, and disaster preparedness. So we have a number of collaborators, some from Johns Hopkins and some from our partner institutions. And these are spread around these different areas in which we are going to be creating these educational modules. So we have detection technologies, in which we have Dr. Pete DiCarlo and Dr. Karsten Prasse, who are in the Whiting School of Engineering, but in environmental engineering, environmental health and engineering. We have another module on vulnerable occupational populations, where we have Dr. Leslie M. Quiroz-Alcala and Dr. Anna Pollack from George Mason University. We have Dr. Megan Davis and Dr. James Blando from Old Dominion University working on exposure assessment and mitigation. Dr. Amir Sapkota from University of Maryland and Dan Barnett from here on disaster preparedness. And then lastly, Dr. Anna Rule and myself working on sustainable production. And so today, actually, I'm joined by Dr. Anna Rule, who's in the room with me, and she'll be talking about one aspect of our research training in a bit. So our center is sort of organized in this fashion. We have these 4 areas of emerging technologies that we want to focus on: additive manufacturing, nanobiotechnology, emerging disinfection technologies, and electronic nicotine delivery systems, or e-cigarettes. On the left-hand side, you see these different module cores that we talked about in the previous slide: sustainable production, detection technologies, exposure assessment, disaster preparedness, and vulnerable populations. And we are synthesizing these emerging technologies and using them as examples in these different module cores, and create a variety of online products. So we have online modules that these modules will be incorporated into online courses, to degree programs and research experiences, continuing education courses, as well as just-in-time training for public health and other workers for emerging disasters. These products will be disseminated through our Center for Teaching and Learning through their courses, Coursera, webinars, and mini courses, YouTube, and also in-class content. And our audience for this are not only our own students at our partner institutions and Johns Hopkins University, but also anywhere else, instructors anywhere who want to use and access this content, and sustainability managers who want to look at sustainability issues, EHS professionals, company managers, employees, public health workers, healthcare providers. So the first specific aim is, as I mentioned, we are going to develop 5 online courses for professional training of occupational health specialists, engineers, scientists, technicians, and instructors. And the areas, again, I'm not going to repeat them again, but these are the 5 areas in which we'll be developing these online courses. And each core will contain 10 web-based modules, and each module is roughly an hour. And so at the end of our 5 years, we hope to have created 50 one-hour modules that can be accessed by whoever wants to access them. But I also want to point out that these are not one-hour videos, although they can be viewed as that, but they are broken up into smaller segments. So each segment can be as short as a few minutes, maybe 5 minutes, to as much as 15, but no one video is more than 15, 20 minutes long. And so these are stitched together to create these 1 hour long modules, and then they are then stitched further up to create longer course content. So the first thing I want to show you is our YouTube channel. And I want to, before I go to the actual channel, I want to show some statistics for it. So we have 81 subscribers, and here are the number of videos. Like I said, these are video times range from 10 to 25 minutes. So we have a number of videos in each of these different areas. And we have in total about around 5,700, 5,800 views as of April 26th. So I want to quickly go over to the YouTube channel and show you that, and hopefully you all can see this. And so we have the POccET map, and as you can see, I have subscribed to it too. So so this is how the page appears to you. So we have these modules on exposure assessment, and there's quite a few of them around here. Sorry, I did not mean to do that. Hold on, this will come back. Okay. Detection technologies, disaster preparedness and risk management, and vulnerable worker populations. I wanted to share a couple of videos just to give you a flavor of how these look like. And so this is one on by one of our members, Dr. Karsten Prasse, on targeted and untargeted analysis. And I'll just play a brief segment from it just to give you a flavor.
One way and how I like to envision this is kind of thinking about when you walk down a street at night.
So that was the first video I want to share. And a second one, this is on so that was on Monte Carlo uncertainty analysis. So our modules span the range of content from sort of targeting chemists as well as exposure assessors. But these this content is actually accessible by the goal is to have them accessible by graduate students, but also by professionals in the field. So let me get back to my presentation. I'm going to skip this slide since I just showed it to you. Okay. Our second specific aim is to use these modules in online course. First goal is to enrich our existing occupational health and safety curricula by offering blended learning courses that emphasize the applications of OHS principles to the study of emerging technologies. And then I'll talk about this next. And then I'll also talk about our development of a new online master's program in product stewardship and our progress towards that goal, and how we are using or planning to use some of these modules for training, just-in-time training for disaster preparedness for frontline workers. And then finally, how do we create continuing education courses for professionals and instructors in OHS applicable to emerging technologies. So in terms of enriching our existing curricula, I'm just giving you an example from Johns Hopkins before I move to other universities. So we are incorporating these materials into our existing courses at our school in our department. So we have a course that I teach called Exposure Assessment Techniques for Health Risk Management. There is a course that Dr. Leslie Amkiros-Alcala teaches on health of vulnerable worker populations. And then there's a third course on total worker health that is taught by Dr. Megan Davis. So if you just sort of click on one of them, hope this works. We can go here, and if you just look at the content, let's see, and look at, let's say, lecture 3, and you can see a bunch of reading materials, but also you can see on the right-hand side these videos. So these are the videos that were created as part of POccET Map. And I'm not going to play them right now, but these are exactly the same things that we have on our YouTube site as well. So you see these are 2 sub-modules. So they are 7 minutes and 13 seconds and 16 minutes. So they are much less than 1 hour in length, but that's the idea, that we can stitch together entire lectures using these modules. So now moving to one of our partners, Old Dominion University. Our partner Jim Blando is actually going to Kyrgyzstan very soon as part of his Fulbright Specialist Project to work with the International School of Medicine there, as well as the Ministry of Health, and will be demonstrating the utility of POccET Map for their missions, and to encourage the use of these modules and incorporate them in their programs. Within Old Dominion University itself, these modules are used in one of their courses on environmental and occupational risk assessment. And then there is this picture on the right-hand side. You see one of the students, an undergraduate student and an MPH student, who are involved in development and of these modules, and looking at noise surveys among firefighters. So these are eventually being, and we don't have that module completely ready yet, but it's being processed right now. The next goal is to create a master's program in product stewardship. Product stewardship is basically defined as the responsible management of health, safety, and environmental aspects of the production of anything, from the raw material stage to their final finished product, and then eventually its recycling and disposal. And basically the idea is that a company manages its products from their inception to disposal, cradle to grave management of these materials. And as you can see, It sort of includes everything from sustainable product design and development, product safety testing, exposure and risk assessment, awareness of safety regulations, recycling and take back, hazardous and banned substance management, safety data sheets, transportation, everything. And in fact, the American Industrial Hygiene Association for a while had its a whole day of its conference devoted to product stewardship. This eventually spun off, and there is now a product stewardship society. And so we felt like there is a market here for creating a master's program here. But we started off small. We said, let's start off with a certificate program. So this is an entirely online 18 credit. So these are 18 quarter credits, not a semester credit, 18 credits program designed for people in the corporate sector, junior, mid-level, or even executive level professionals who are non-degree seeking students. They would get a certificate at the end of this program. And we expect that people who are taking this would have backgrounds in environmental health, regulatory compliance, industrial hygiene, OHS, sustainability, the list goes on. It's also, of course, open to our master's and doctoral degree students. Very briefly, the program requirements are the second set of courses here. There's Intro to Risk Sciences, and there's a course on energy and environment that looks at life cycle analysis. Designing for Sustainability looks at sustainability, industrial processes, and pollution prevention. And then there's a bunch of environmental health law and toxicology courses. So that's our sort of startup, but we are eventually thinking there'll be a master's program. And so here's our thinking around that, that there'll be courses on toxicology, environmental chemistry, exposure assessment. That's the course I talked to you, which already exists, for which we have used POccET map modules, risk assessment, sustainability, product safety testing, and so on. There are also courses on environmental law, regulatory talks, and economics, public policy, and so on. And so you can see on the right-hand side, so there's like technical competency rubrics, regulatory competency, and professional competency rubrics that we need to meet. And then there's a bunch of electives as well. We are also, as some of you may know, Johns Hopkins also is the home for a NIOSH-funded Education and Research Center, ERC, that is funded by NIOSH. And we, in addition to training graduate students in occupational safety and health, we also have a continuing education program. And so we have been working with the ERC for creating modules that target a whole range of occupations: physicians, physician assistants, nurses, nurse practitioners, industrial hygienists, safety professionals, and so on. And again, it's a very easy process for us to disseminate the modules through our ERC. Lastly, in specific aim 2, we are also reaching out to vulnerable worker populations, and that's one of the courses that we offer. So this is one example that I wanted to highlight that is being led by Dr. Leslie M. Quiroz-Alcala. She is a faculty member in our department, a member of the faculty member in the ERC, and also a partner in the POccET map R25. And so this is an outreach she had to a hairdressing salon, one of many. And Katrina Randolph, you see in the top picture, is a member of the Health Advocates in Reach and Research. It's a program that engages barbershops in Baltimore City. And so she was recruited for a study on chemical exposures by Leslie M. that measures levels of chemicals in the air and also in the stylist's urine. Rather than talk about this myself, I want to show you a quick video.
Health was my driving passion. Help others, but also rich on history.
Fortunately, the audio is not coming through.
Oh, it's not? Okay. Okay, let's stop that then. Basically, what the audio says is that women have greater exposures to these chemicals used in hair products, and women of color use more types and greater quantities of these hair care products. They may be at a higher risk than others. And so what Leslie M is working on is looking at these exposures of these hairdressers. And this is again a nice synergy between our POccET map, where these modules are being created, and the ERC that provided pilot funding for her. And then now she has recently been awarded a NIH grant to look at an R01 grant to look at these exposures. And lastly, here are some of the modules that have been created for disaster preparedness and risk management. And we are, Dr. Dan Barnett has been in touch with the Maryland Department of Health, as well as the city of Baltimore, to further disseminate these modules to the employees in those agencies. And lastly, I want to talk about specific aim 3, which is about creating lab and field-based research experiences for our students in OHS relating to emerging technologies. So the first one is actually on ethylene oxide monitoring, and this was led by Dr. Pete DiCarlo. Ethylene oxide is a hazardous air pollutant, and it's primarily used for sterilization of medical devices in the US, as well as spice and tree nut fumigation in the ag sector. And it's a chemical feedstock for a variety of other chemicals as well. More recently, actually, let me just go back. So there is according to the EPA IRIS system, there's a 1 in 10,000 cancer risk for a lifetime exposure of 11 parts per trillion by volume. And that part per trillion becomes important in a second. And EPA has come out with new rules for facilities using or producing ethylene oxide. So this is a very topical issue. And so this is a research activity that sort of targets this very topical chemical, but also trains students in the use of advanced technologies. And in this case, it's called the cavity ring down spectroscopy. And this is a method for detecting chemicals at very, very low concentrations. As we all know, light is absorbed at specific frequencies, specific to each chemical molecule. But the greater the distance that the light travels through a sample, the greater is the absorption of light. And so if you have a very low concentration, very few molecules, you really need the light to travel a long distance through this environment. And so the ring down spectroscopy achieves that by basically creating a cavity in which the light sort of reflects back and forth many, many times. So 45,000 feet or 8.5 miles. And this long path length results in parts per billion sensitivity. So this is a picture of the setup. And what this study did was to look at two different labs, one in which ethylene oxide was being used for sterilization, and a different lab in which that did not happen. So it's sort of a control environment. And so here are the results from it. So laboratory 1, which is where the sterilization was happening, the measurements were of the order of 65 parts per trillion. And laboratory 2, where which is the control, the levels were around 1 part per trillion. And so this shows that the instrument that we're using, it is able to detect concentrations at that low level and is able to detect differences at those levels. A number of our graduate students were involved in this field trial. It was in-house, and it was a nice exercise for our students in different labs, as well as Dr. Pete DiCarlo's students themselves. A second research experience is looking at the treatment of PFAS in groundwater. And so this was led by Dr. Karsten Prase's lab, and the paper was published based on that. So Stephen Chow is a postdoc in our department in Dr. Karsten Prase's lab. And so what this is showing is treatment of PFAS contaminated groundwater. So the team basically took these groundwater in holding tanks and passed them through different columns. One with granular activated carbon, GAC, the other one with anion exchange resin. And so what is being plotted on the x-axis are bed volumes, or how many months of treatment is needed. So 150 bed volume is roughly 15 months. And so, and what is being shown are the fraction remaining in the treated water. So if there is breakthrough through the columns. So what we're seeing is, and there are like these different chain lengths. And so what we're seeing is for both GAC and the anion exchange, shorter chain compounds are breaking through quicker than longer chain ones. For perfluorinated carboxylic acids. And the bottom two graphs show that for perfluorinated sulfonic acids, the anion exchange resins actually don't break through as easily. So much superior in that way. And so this is an example where our students are involved in research that is directly relevant to POccET map. They are engaged in creating modules for POccET map. A third research experience looks at peroxyacetic acid exposures in healthcare workers. So in healthcare settings, a number of disinfectants are used, but we are focused on peroxyacetic acid or peracetic acid. It typically is found in combination with hydrogen peroxide and acetic acid. It's typically used in diluted form. And in this particular case, we use dilution about actually 5%, not 0.5%. The health effects include skin irritation, eye irritation, upper respiratory irritation, and so on. It's actually quite commonly used in the Johns Hopkins hospitals. There have been a number of complaints about it among the janitorial staff about the use of this particular compound. And so we did a study looking at sampling them and also looking at the evaporation rate of peroxyacetic acid. So we used a monitor it's an electrochemical sensor called SafeSide, and 0 to 3 parts per million. So we did a modeling study in an exposure chamber where one of our graduate students, Ryan Hines, shown here, wearing a mask and everything. And we basically mimicked typical cleaning tasks that healthcare workers do. So they are cleaning surfaces, like shown here in the top right, and then cleaning walls, mopping floors. And we have a chamber here which is capable of a wide range of air changes per hour. So it actually goes up to 20 air changes per hour, but we tested these experiments were done between 2 to 8 air changes per hour. And we have Ryan wearing this ChemDAC monitor on his lapel. And so I'm going to show you some results. So actually, before I do that, so we used a well-mixed room model, and so we have the airflow through the chamber, which is denoted by Q, the generation rate, depending on each step, each wipe. So that's a function of time, the G. And what we wanted to find out was this KL, which is the evaporation rate, the evaporation rate of peroxyacetic acid, and V is the volume of the chamber. Before we get to that, I just want to quickly point out that the ACGI short-term exposure limit is 0.4 parts per million. And as you can see here, within a few minutes, you don't even have to wait 15 minutes. Within a few minutes, the short-term exposure limit is exceeded, and it goes well beyond the STEL. Ryan then determined the evaporation rate constant, which is K here in inverse minutes. And we can see that the surface roughness, the different surfaces were tested, different wind speeds, and different ventilation did not really make a whole lot of difference to the evaporation rate constant. Again, compared a model to the measurements, and so the solid line is our model prediction compared to the 3 blue dotted lines. These are the measurements, and these light pink envelopes, these are the upper and lower confidence intervals for the model predictions. So the model, it sort of performs reasonably well for different air changes per hour. For my last research experience, I'm going to pass over the screen to my colleague, Dr. Anna Rule, who led this portion of the study.
Thank you. How much time do you have? This not a lot, right?
Yeah.
Okay.
Unfortunately, we only have about a minute or two.
Right. So I'll breeze through this, but so as I think most people know, these electronic cigarettes are just flooding the market. It has been a huge struggle to kind of playing whack-a-mole with FDA trying to regulate, and then another thing coming up in the market. There's many chemicals of concern found in electronic cigarette aerosols, and we had one of our postdocs actually do a really interesting study with Dr. POccET on non-targeted analysis, and found a lot of, I think, up to 2,000 compounds. But most of my research is on metals of the electronic cigarettes, so that's what I'm going to focus on for now, although this paper is on the big landscape of non-targeted analysis. And the reason we focus on metals is because the coil that heats up the liquid to generate the aerosol is metal. And so we have found, and this is another one of my postdocs, Dr. Herrera, she found metals in aerosols by device type. All of the devices that we test contain metals. As you can see, there's a large variability between the metals, and some of the metals in higher concentrations in some of the types of devices than others. And concerning the new devices that are the disposable electronic cigarettes, we're finding that they have higher zinc and cobalt, for example. There was another project looking at arsenic in the different devices led by Dr. Charani again, and then one of our doctoral students is leading the charge with looking at the metals in some of the biospecimens. We're collecting urine, saliva, exhale, breath condensate, and blood from participants that bring their devices, and we collect the device aerosols. So that's all I have.
Thank you, Anna. I'll stop sharing, and we are happy to take questions.
Yeah, thank you, Dr. Ram and guests, for giving us the time to really go in depth, and we appreciate all those tools and resources that you shared, and taking the time to make sure that the audience is able to access them. For those in the audience, if you have questions, once again, please put them in the chat or in the Q&A function. While we are waiting for some questions maybe to roll in, I'm wondering, are you guys collaborating with other R25s?
Yes. So it's funny you should mention. So our previous presenter, the Interact. So we have been collaborating with Interact, and especially around issues on additive manufacturing. And our plan is that some of the modules we are going to co-brand. So they'll be both branded as Interact as well as POccET Map. And we can share content and reach broader audiences that way. There is already one module that we are that has been produced by Interact that we are thinking that we will also disseminate through our channels. And so we are just still working through the copyright logistics. I mean, these are all like common license, or I'm forgetting what the terminology is. But anyway, they're all common license, but we are sort of waiting for University of Minnesota to sort of give us formal permission for that. So
yeah, I appreciate that.
Continue that, and we'll share, of course, our modules with Interact. So
yeah, thank you. And I'm just wondering about the status of that MS program in sustainability. Do you have anything about that?
Yeah. So so what happens is, so even for our certificate program, we cannot just create a certificate and put it online or whatever. It has to be approved by the Maryland Higher Education Commission. So and that's a whole process in itself. So we got the certificate, we got permission for that, and so we are so finally it's on the books, and we are waiting for our students, but we are not waiting for it to be proven to be success before we go on to the masters. We are already starting the planning for the masters. We have the curriculum almost ready, and we just need to do the application to the Maryland Higher Education Commission again for that. So I think by next year around this time, I think we should be ready, fingers crossed.
I'm very excited about that. And when you did bring up environmental justice and making sure things are equitable, and you have such a wide audience and such a technical piece of information, I'm wondering, how have you disseminated this training? How have you maybe advertised it to other universities or the public? And if you could share anything about that.
Yeah, so till now, our main venues have been through our own courses. So we are offering courses for our own students on the health of vulnerable populations, as well as through our YouTube channel, and through our investigators on POccET their own sort of individual outreach and activities. And we also have another NIEHS funded project. It's a P30 grant, and maybe Anna, you can talk a little bit about the CHARM initiative.
Yeah, well, it's a P30 with a focus on community environmental health, and so through that, a lot of the same faculty interact with both centers, and so yeah, that's another avenue where we have a lot of community participation and interaction with community members, and so we're trying to also get some of these modules into high schools and through our students to kind of like go down the pipe.
Great. And one of our participants had some technical questions. For example, on slide 6, you were talking about fundamentals to follow for non-target and uncertainty analysis. I'm wondering, what are the fundamentals that you follow for that non-target and uncertainty analysis? And if you could also maybe tell us about why you selected a plug flow conceptual model instead of a continuous flow model.
Okay, so the targeted and non-targeted analysis, I'm not an expert on that, but I don't know, Anna, if you want to talk about that.
Dr. Prase?
Dr. Prase, I can forward that. And also these modules are available on YouTube. So, you know, those are accessible to everybody. And that's one of the, you know, the links that I've sent you, so that can be shared with everybody, and they can explore those. So there's not just one module that I just showed very briefly, is the 20-second clip. There are actually a whole bunch of modules on targeted and non-targeted analysis there. What was the other question? Second question you asked? Oh, for the why not? So the plug flow model. So what we so the well-mixed room model has been you know, in use in indoor air modeling for quite a long time, and it is mathematically sort of amenable to add very different types of generation patterns. So you could have a steady sort of constant generation, or sort of different. And so in this case, the generation pattern is dependent on the person doing the wiping. So if you have one layer, one sort of wipe action, then, you know, there's stuff you know, evaporating from the surface. Then you have a second wipe coming on top. Then you have a second layer. And so, you know, the model, mathematically, it makes it sort of tractable to deal with such a complex situation. So that's the main reason we chose that particular framework.
Yeah, thank you for clarifying for us. And one more question before we start wrapping it up. You know, will the trainees conducting the lab experiences then train other trainees in what they learned?
Oh, absolutely. So I showed you one example of Ryan Hines doing that work on the peroxyacetic acid. So he is now, in fact, developed a module on using modeling as well as chamber studies to develop emission rates for volatile substances. And so that is going to be a training module that we'll add to our POccET Map YouTube site. And that's just an example. So we have a bunch of other doctoral students doing similar activities. So they are going to be doing exactly what you're saying, which is create more modules. And
if I may add, like, for example, on the electronic cigarette project, we have the postdoc training the doctoral students so that they can, 2 of them are doing their doctoral dissertations on it. And we have 3 master students that are helping recruit and helping collect the data and helping so definitely the different generations And it's really cool to see the postdoc mentoring and then the doctoral student getting a little mentoring also for the master students.
Yeah, thank you. Thank you for answering all those questions and, laying out all that information. Once again, making these tangible with tools and resources, and those web links are provided throughout the chat for the audience members to look to. So thank you again, and we're actually going to head on now to our last speaker. So
Thank you.
yeah, thank you.